Mom, are you there? Okay, let's start. So we are done with the nomenclature. Now we are going to talk about a structure of the carbonyl compound. As I told you, what is carbonyl compound? So basically, carbonyl compound is the one in which C double bond O is present. C double bond O is present. That is your carbonyl compound. Let's say if you have this C double bond O like this, what will happen here? So as you know that this carbon will be sp2 hybridized, so the structure will be trigonal plane. So any one of you, can anyone tell me this carbonyl will be acting as nucleophile or electrophile? Please let me know. What is nucleophile or electrophile? I hope you both of you know this term, are aware of this term. Yes or no? Okay, tell me, this carbonyl compound is your nucleophile or electrophile? How it is electrophile? Umam, are you there? Not
Yes, sir.
respond. Okay, so tell me whether it is acting as nucleophile, electrophile. See, what I want to tell you is that this type of carbonyl compound, when you are going to see, first of all, I'm just going to revise a little bit of nucleophile and electrophile. See, this nucleophile is the one which is electron rich species, They are electron rich species. Or you can say basically nucleo, that comes from nucleus, and phile, that means lover or affection for nucleus. And here nucleus means positive. And whenever a compound, generally, whenever a compound has positive charge, that will have electron deficiency. So basically, electrophile means it goes to that part of any compound which has electron deficiency. That means electrophilic center. So basically, nucleophile itself is an electron rich species, and who will love, basically, who will be affected or affection towards the one which is having electron deficiency. Are you getting my point?
Yes.
Electrophile is means electron lover, electron loving or electron lover or electron seeking, you can say. So basically this electrophile itself is electron deficient compound. Are you getting my point? Now,
Yes.
generally, which one is nucleophile? So the one which is having negative charge or the one who has lone pair. The one which is having lone pair, they will be acting as nucleophile because, as you can see, they will have lone pair, they can donate. That's why they will be acting as nucleophile. And the one which is having electron deficient, or you can say, or positive charge on them, then it will be acting as electrophile. It loves the one which is having more electron. That means it will love nucleophile. It will have affection towards nucleophile. Also, this electron deficient, like if I will tell you BF3 is an electrophile or nucleophile, what do you think? And why do you think so? If you don't have any answer, just let me know. Don't waste time. See, BF3, if I'm going to tell you, your voice is very low, Austin. So try to type it, or else you should speak louder. BF3, that means it is making three bond. Boron is making three bond with three fluorine. One bond, that means two electron. There is no lone pair on boron. So one bond, two electron, three bond, six electron. How many electron it should have? Eight electron, but it is having six electron. That means it is having deficiency of electron. So this BF3 will be acting as electrophile. If there is H plus, so H plus will be your electrophile. Are you getting my point?
Yes.
If I'm going to tell you OH negative, negative is the charge there. So this will be acting as nucleophile. Now tell me, what is this, electrophile or nucleophile?
Nucleophile.
What do you think, Stin?
Exactly.
Okay. Now, this is what I wanted to tell you. What I told you is the one, the basically this carbonate, it is not necessary that if any compound having 8 electron or more than 8 electron, it will be nucleophile. It can act as electrophile as well. See, the general things are same as it is, but there are some compounds that will be acting as electrophile or nucleophile. It will be reverse or something like that. You can see C double bond O is there and it can act as nucleophile. That is true because it has lone pair, simple. But at the same time, I told you that this will be acting as electrophile. How it is possible? So see this carbon and oxygen double bond. Oxygen is the second most electronegative element in the periodic table. So this oxygen will take electron from carbon. So what it will be? O negative, and this will be like this. And since carbon donated its electron to oxygen, there will be positive charge. So basically it can act as electrophile as well. Or we say that this compound has both center, nucleophilic center and electrophilic center. Are you getting my point?
Yes.
Yes.
Okay, so just write it. I'll give you some homework. Yesterday, Humam, I gave you homework. What about that homework?
Sir, I wasn't able to complete it. Few only I did. They were a little bit hard.
Okay, no problem. Share with me whatever you have completed. Share with me. Okay.
Yes, sir, after class I'll share it.
Okay. Let me know when you are done with this.
Done so.
Oh, very good. Now I'm going to give you again a homework for you, which is basically related to class 11th and previous chapter as well. So here we are going to start. The main topic is your preparation of aldehydes and ketones. Preparation of aldehyde and ketones. The first one that I'm going to write, this is especially both this with this method, preparation of aldehyde and ketones. With this method, you can use to find out both. You can use to prepare both aldehyde and ketones. So the first one is by oxidation of alcohols. We already studied this in previous chapter. The second one is by dehydrogenation. Dehydrogenation of alcohols. The third one is from hydrocarbon, and we have two methods to prepare from hydrocarbon. The first one that you are going to see is about by ozonolysis. Have you heard of this? By ozonolysis of alkenes. And the second one is your by hydration of alkynes. By hydration of alkynes. So all I want to say is that these topics that you already have studied, I want you to write a short notes and reaction as well. Like the way I teach you, write the topic and then write a statement about this. And according to the statement, I write a reaction and then give you example. So this is your homework and I want it mm, by Saturday. I'm giving you one more day, like Friday. You have holiday, you can do this, right? Austin, your paper is over or you are still busy in paper? I'm not able to hear you. Okay. If you got some time, please do this. It won't take much time, like half an hour. That is more than enough. So will you be able to complete it, or if you want to do it, you can give it on Tuesday. What about you, Huma?
I can complete it.
Okay, so please do complete it. And Austin, if you are busy in exam, so let it be. By Tuesday, you can give me. Okay. So let's start today's topic, and that is especially. You can take a screenshot of this. How will you prepare? In NCERT, it is given basically. You can look at that as well. This chapter is full of name reactions. So write the list of name reaction as well. You know, you have to do work. You have to work hard in order to get good marks. Can I change the slide now? Okay. Okay, let's start. So basically, this method is preparation of aldehydes. This is especially for aldehydes. And the first preparation I'm going to do, it will be from acyl halide or acyl chloride. So this is from acyl chloride, or we can directly write from acid chloride. Acyl halide is a functional group, as I told you. Now see what happens. So basically this reaction is very easy, and from this reaction we prepare aldehyde, which is connected to a benzene. So that will be your benzaldehyde. And this reaction has a name that is known as Rosenmund reduction. That means you are going to reduce this acyl chloride, basically benzoyl chloride, you are going to reduce to get benzaldehyde. So basically I'm going to write a point. aryl chloride. That means you know that chlorobenzene. If you're going to see the nomenclature, this will be chlorobenzene. Is hydrogenated. Hydrogenated. That means you are going to hydrogenate it, add hydrogen over catalyst, catalyst palladium. PD, that means palladium, you can write the whole name palladium PD. On barium sulfate. On barium sulfate. You know the formula of the barium sulfate, that is BaSO4. And this reaction you will get benzaldehyde, and this reaction, RXN stand for reaction, is known as Rosenmund reduction, is known as Rosenmund reduction. Now see how the reaction will take place. I will show you. Very simple it is. The reaction is very, very simple. So here we have benzoyl chloride. So this is your benzoyl chloride. C double bond O Cl. And now you are going to react this benzoyl chloride H2 and palladium in the presence of BaSO4. So what you will get, this chlorine basically, wait a minute, this chlorine will be replaced by hydrogen, and you will be getting something like this. This is your benzene, C double bond O and H. So reduction, everyone knows that addition of hydrogen is called reduction. So this is your benzoyl chloride. And if you want to improve your nomenclature, then you should write nomenclature of every product that you make in a reaction of benzaldehyde. Benzaldehyde. I think it's easy, right? Let me know when you are done with this.
Done, sir.
Okay. The next preparation from this is from nitriles. That means basically cyanide and esters, in which we will get a name reaction here as well. Now see, from nitriles and esters. So first I'm going to show you from nitriles. Basically, this reaction has a name that is called a Stephen reaction. And basically, we are going to reduce nitriles in the presence of nitrous acid, not nitrous acid, stannous chloride. So I'm going to write a point. Nitriles are reduced to corresponding imine. I'll show you. Imine is also a functional group. Corresponding imine. What is imine called? So basically, imine is basically RCH double bond NH. Just wait a minute. Oh, sorry. So basically, from nitriles, how do we prepare aldehyde? So basically, what you are going to do, you are going to react this nitriles with stannous chloride in the presence of HCl. You will get amine, imine. Imine. This is imine. When you have CH double bond NH and this CH is connected with alkyl group, that is imine basically. So how the reaction will proceed? So you have RCN, that is nitriles of cyanide, and you are going to react with stannous chloride SnCl2 in the presence of HCl. So what will happen? So basically this will be directly converting into RCH double bond NH, double bond NH. And after this, you are going to do the hydrolysis in the presence of acid. HCl is there. What will happen? This will be converted into RCHO. This will be converted into RCHO. That means it will be converted into aldehyde. Are you getting my point, both of you? Once again, I will show you how the reaction will take place so that you will be able to understand this. You know that this RCN is having triple bond. So when you are going to react with stannous chloride in the presence of HCl, due to this, there will be generation of hydrogen. And now see what will happen. This one bond will be broken and it will be reduced. You can see reduced. Reduced, that means addition of hydrogen. So hydrogen is added here, hydrogen is added here. So it will become RCH double bond NH. Are you getting my point, both of you? Now, after this, what will happen? After this, what will happen? H3O positive is there. Just wait, right? Please wait. Sometimes it abruptly closed. Are you there? Sometimes it abruptly closed. The window might close. Okay. Now see what will happen. Very simple. So basically this whole will be gone and oxygen will be added. So you will get RCH double bond O. That means RC double bond OH. Are you getting my point? Aldehyde. This is how you will get aldehyde from the Stephen reaction, and we can write this reaction RXN is called. You are not going to write in exam RXN. The marks will be deducted. So please be careful. The Stephen reaction. Let me know when you are done with this. So this is the preparation of aldehyde from nitriles, that means cyanide. I also wrote in the topic that preparation from ester. So there is another method to prepare aldehyde from this ester. Let me know when you are done with this.
You're done.
Okay, alternative. I'm going to show you. Basically, with the help of nitriles, nitriles are selectively reduced by diisobutyl aluminum hydride, butyl ammonium hydride. In short form, we can write diable H to imine. In this process, also imine will form, followed by hydrolysis. Followed by hydrolysis, and you will get aldehyde. Now I'm going to show you the reaction. Very simple it is. This is your RCN. In the first step, you are going to use H2, diable H, or you can write AlH I butyl Bu whole twice because it is diiso. Then you will be getting RCH double bond NH, and after this you are going to do hydrolysis. Then you will directly get RCH. Is that clear?
Yes.
So basically RCN directly you can write RCHO. At the place of nitrogen, you can change this. I'm going to give you a question from NCERT. In one step, you can do ALH whole twice, and in the second, H2. So directly you can write from this if both are written here. So in this step, directly you can write RCHO at the place of imine. Let me know when you are done with this.
Done.
What is the product you have written? Simple, what you need to do at the place of N, the rest part will be as it is CH3, CH double bond, CH, then CH2, then CH2, and then directly you can write CHO. And please write the nomenclature of this. Are you done with this?
Yes.
So what is the name of this? This is a functional group. This is double bond. So we are going to give preference to functional group 1, 2, 3, 4, 5, 6. No branch. Jump to the parent chain. How many carbon? 6. So hex 4 in nature of bond and 1 al. Or we can directly write hex 4e null. Is that clear?
Yes.
Okay. Now, similarly, we can prepare from ester as well. We can prepare from ester as well. So how we are going to prepare? So basically, ester will also be reduced to aldehyde. Esters are also reduced to aldehydes with dibyl H. Dibyl H is the short form. They can ask you the full form as well. So diisobutyl aluminum. So diisobutyl aluminum hydride. Now, how you are going to do it? Very simple it is. If you have CH3, CH2, CH2, let's say, and this is your C double bond O, CH2, CH3, and you are going to follow the same reagent, dibyl H, and followed by hydrolysis. What you will get, very simple it is, you just need to remove any part of this. You can see, oh, wait a minute, I have done a mistake. This is ketone I wrote it. Now, this is your ester. So you just need to remove this, add hydrogen. You will get CH3, CH2, CH2, and then C double bond OH. So this is what you Are you done with this?
Yes, sir.
Okay. Now the next preparation of aldehyde is your from hydrocarbon. The second we have from hydrocarbons. In hydrocarbon, we are going to do the first one by methyl oxidation of methyl benzene, by oxidation of methyl benzene. And in this, there are two ways to oxidize methyl to convert into aldehyde. And in this, we have the first one, use of chromyl chloride. Use of chromyl chloride. That means CrO2Cl2. Is that clear?
Yes.
Now see, very simple it is. What this is also a name reaction. If you have this CH3, methyl benzene, or we can call it toluene, you are going to react this with CrO2Cl2, chromyl chloride in the presence of carbon disulfide. So you know what will happen. Very simple it is. Both the hydrogen from carbon will be removed. Three hydrogen is there and one hydrogen will be there. Now this, can I write it like CrO2 is there. So OCRO and then Cl2 is there. So Cl2 and whole twice. Basically what I just did is very simple. There is CH3. Okay, so one hydrogen will be replaced by this CrO2Cl2. So basically OCROCl2, another hydrogen replaced OCROCl2, and then one hydrogen was there, and this is connected with the benzene ring, something like this. So I wrote it together O2Cl2, and after this, what you need to do the hydrolysis H3O positive, and what you will get directly benzaldehyde. You will get benzaldehyde, or here you can write benzaldehyde. Is that clear?
Yes.
Please do write it. And this reaction is known as Ettard reaction. Let me know when you are done with this.
Done. Sir.
Very good. Now, the next from hydrocarbon is very simple. It is similar to this one. And this is use of chromic oxide. That means CrO3. Okay, chromic oxide. So basically, in this toluene, we are going to prepare the same benzaldehyde. This is your toluene, CH3 you can use. And you are going to react with this with CrO3 in the presence of peroxide, that is Ca3. CO hold twice O and at cold temperature like 0 to 5 degrees centigrade. So what will happen here? This again hydrogen will come into play. This is your benzene, and here hydrogen will be two hydrogen will be removed, and this OCOCH3. That means OCOCH3 whole twice will be there, followed by hydrolysis and heat. You will directly get benzaldehyde. Let me know when you are done with this.
Done.
Very good. Both of you done. So this is the next one. Now after this, the second way to prepare from hydrocarbon is very simple. Three ways we have three method. So basically this is by side chain chlorination. This is also very easy and similar. By side chain chlorination followed by hydrolysis. Now see, it's also very easy. Again, you are going to take what? You are going to take the same thing, that is toluene or methyl benzene. You are going to do the side chain chlorination, and chlorination or halogenation only takes place in single bond. So this hydrogen can be removed, but this doubly bonded carbon, hydrogen with doubly bonded carbon, you cannot remove. Okay. It is a stronger bond like that. So what it will be? Very simple. This is your benzene, and you are going to remove two hydrogen, replace, substitution reaction took place. So it will be CHCl2. And after this you did side chain chlorination followed by hydrolysis. That means you are going to react this with water at 100 degrees centigrade. That means 373 Kelvin. So this chlorine will be removed and OH will be added twice. Basically, this will be like this. You know that this will be hydrogen. One chlorine is removed and from water OH is added, and one chlorine is another chlorine is removed and you will get OH added. Now what will happen? Basically, on one carbon, on a single carbon, two OH is not stable. So you are going to remove H2O here. So what you will get, see, this is what you will get, hydrogen. Now carbon is making only two bond. It needs to make four total. So double bond O. So what you are getting is very simple. That is benzaldehyde. Are you getting my point?
Yes.
Hello. Now,
Done, sir.
what did you say? Are you done?
Yes.
The next one, third one from hydrocarbon is very simple and it is a name reaction. And this is by Gatterman coached reaction. Make a list of all the name reactions from every chapter. Like the last two chapter we already have completed. Did you make the list of name reaction? No. So please try to make it. Now, so basically it's very easy. When you, what you are going to do is you're going to react benzene. You are going to react benzene with CO, carbon monoxide, in the presence of HCl, and anhydrous AlCl3 in the presence of CuCl. You know, after this reagent, when they are going to react, they will produce CO plus and H. That means you will directly get CHO, and which will attack on this ring, and you will get CHO, benzaldehyde. And this reaction, benzaldehyde, and this reaction is known as Gatterman-Koch reaction. So I'm going to write point about this benzene or its derivative. That means anything connected with benzene, that is benzene derivative. Benzene and its derivative treated with carbon monoxide and hydrogen chloride and hydrogen chloride in the presence of anhydrous aluminium chloride or cuprous chloride. Cuprous chloride, that means even plus one oxidation state. It gives benzaldehyde or substituted benzaldehyde. This reaction is known as Gatterman-Koch reaction. Let me know when you are done with this.
Done, sir.
Very good. Now we are going to start. This is it for the preparation of aldehyde. The starting portion that I had given you for the homework is basically your uh, preparation of aldehyde ketone. So go through that homework I have given you. Now we are going to do preparation of ketones. Preparation of ketones. You know what? Very less difference in structure. If you are going to see R, this will be aldehyde, a ketone. And if you are going to replace one of the R by hydrogen, this will be, or both, it will be aldehyde. This is your ald and this is your ket. Okay. Now for preparation of ketones, we are going to start from the first one is from acyl chloride. From acyl chloride. Now see what you need to do. First, you need to treatment. First, you need to prepare alkyl cadmium. You need to prepare alkyl cadmium, and how you are going to prepare alkyl cadmium? You are going to react cadmium chloride with Grignard. So treatment of acyl chloride, I'm going to write acyl chloride with dialkyl cadmium. I should say dialkyl cadmium. And this cadmium, dialkyl cadmium, prepared by, we need to prepare dialkyl cadmium as well, prepared by reaction of cadmium chloride, reaction of cadmium chloride with Grignard reagent, with Grignard reagent gives ketone, with Grignard reagent gives ketone. Now you can see how the reaction will go. Very easy it is. Let me show you. See, first you are going to react Grignard. You are going to take 2 moles of RMGX Grignard and react with this cadmium chloride. Then what will happen? Very simple. You know that this is negative, this is positive, this is positive, and this is negative. So this negative will be directly coming here. So it becomes R. Oh, wait a minute, wait a minute. Positive directly going to negative. So it becomes R2CD along with MgXCl. So what we can write 2MgX and Cl. And this dialkyl cadmium, you are going to react this with acyl chloride. This is your acyl chloride, and you are going to react this with R2CD. So what you will get, very simple it is. You can see this is negative, this is positive, this is negative, and this is positive because cadmium is a metal. So this will be attacking negative part on this, and you will get directly to, let's say this is R dash, or you can take R as well, and this R will come here. And cadmium chloride, the one which you have used here, will again you will get it. Again, you can react this with Grignard to get dialkyl cadmium. Again, that dialkyl cadmium will be reacting with acyl chloride to get you ketone. I think it's clear to both of you, right? Yes, right.
Done, sir.
Very good. Is there any doubt that you want to ask?
Now, sir.
Okay, I'll give you some UPSC. I'll write the name of this. Paste it. Any answer, both of you? First is 2-oxo butene. Butene, that is wrong, Huma. This is 1, 2, 3, 4. And why you are using oxo? This is the main functional group, right? There is no substituent. So we are going to write but. And then you can see at third position it is in, and at second position it is on. When ketone is main functional group, you are going to use on, na? Yes or no?
Oh, yes, sir.
And for this main functional group is aldehyde. So 1, 2, it's better to go with this 1, 2, 3, 4. Now this is your branch, this is your branch, this is your branch. So you are going to write it in alphabetical order. When alcohol is used as a branch, what its name? Hydroxy. So 4-hydroxy. Then comes your 2-methyl. Then comes your 3-oxo. Now since it is used as a branch, so 3-oxo and butanal. Butane 1-ol or butanal.